Hello everyone, this is V. Manikyala Rao, working as assistant professor in the department of CSCA and ML in BVRIT Nasapur. Today we want to discuss about Chameleon method and density based methods in the data mining. So what is Chameleon method? So Chameleon is the other name. What they are invented means, so I taken the architecture for the Chameleon. So first we are taken some data set, and by using KNN, k nearest neighbor algorithm, we are finding the nearest neighbors, and then they need to partition in the form of graph, and based on that we have to identify the relative interconnectivity and relative closeness. Relative interconnectivity means the given points. For example, I taken C1 and C2. These two are having any interconnection means we need to include C1 and C2 into our cluster point. Relative closeness means the internal values that are to be matched with the given clusters. So now I will give an example. You will understand what is to be happening in the given example. So see here, let us consider we are taking the points, 6 points we are taken here. First one, we have to frame the k nearest neighbor graph for this. So for that, what we have to do means we need to calculate the Euclidean distance between the points. This is called it as Euclidean distance. So how we are calculating the Euclidean distance means, in the Euclidean distance, the sum of the points, so A to B, C to D and E to F, two points we are calculated, then the edges between the points 3 or 1. So now we are dividing that one into the clusters. AB belongs to cluster 1, CD belongs to cluster 2 and CEF belongs to cluster 3. That clusters are written in the subclusters. Then the third one, what we have to do means we need to do first pair and then next clusters. Relative interconnectivity we need to calculate between the cluster 1 and cluster 2. So what we have to do here, so we are having the clusters AB, CD and EF. So now what we have to do means, first A with C, A with D, B with C and B with D. Two pairs we are calculating here. AB and CD. First we are taking only these two. A with CD and B with CD we are calculating the Euclidean distance. Out of all the values, the minimum value in this is 3.61. So B to C is the minimum edge in this. Now next minimum edge we need to calculate. This is the relative interconnectivity between the points A, B, C, D. Then we need to calculate the relative interconnectivity. How we are calculating means the minimum value divided by the cluster values. 1 plus 1 means the cluster 1 contains 1 point and cluster 2 also contains only 1 point. So 1 divided by total 2 clusters are there. So that's why that value we are getting as 3.61. That is the relative interconnectivity for AB, cluster 1 and cluster 2. Next, cluster 2 and cluster 3. That means CD and EF we need to calculate the Euclidean distances between CD and EF. So that means CD to EF, CD to E and CD to F. Like this we are calculating. C to E, C to F and D to E, D to F. In that way we are calculating the minimum value we are finding here is 5.66. Now we need to connect the relative interconnectivity between D and E. So that is 5.66 divided by total 2 points are there. So 1 by 2. So that value is 5.66. Similarly, we need to connect the relative closeness for this. So relative closeness, how we are calculating means, the relative closeness formula means the sum of all the distances divided by count. So that value we are getting is 4.27. So cluster 1 contains A and B and cluster 2 contains C and D. So we are calculating 4.27 for ABCD. Then we need to calculate for CDEF. So I will calculate for CDEF. So that CDEF we are calculating to get that value is cluster 1 and 2 4.27. Cluster 2 and 3 we are getting 6.42. These are the relative connectivities, closeness of the given 2 points. Here AB, CD, AB with CD and here CD with EF comparison, relative closeness. That values we are calculating. Then we need to write that values and to frame the graph. So I written relative interconnect, RI means relative interconnectivity and RC means relative closeness based on that value. So see here, A to B, A, B, C, D. So that A, B, C, D we are calculating here. So A, B with C, D. So we are considering this as C. So A, B with C, D. Then E, F. All the 4 points is to be connected. The distances based on our calculations we are written here. 3.2, some 4.27 means. So that's why I written the line here in this. Like this, this is about the particular algorithm, Chameleon method algorithm. Now coming to the next one, density based clustering algorithms methods. So density based clustering algorithms means we need to find out the densities for the given variables. It is one of the type of unsupervised learning algorithm. So see here, it is used to find out the number of points in the particular region of the data space. So region of the data space means, for example, within that boundary. So see this example, it is an unsupervised learning algorithm. It groups the similar type of clusters into the groups, and that based on the density value. Whatever the density value is to be there, based on that we are framing into our clusters, individual clusters. So now I will show you one by one example. You will understand about the density method, density based methods. So now the first one, density based clustering methods. The first method is DB scan. So in this, while the lower density means points are more spread out. So now see here, DB scan, density based spatial clustering applications with noise. That is called as DB scan algorithm. So it contains only 3 points: noise point, border point, and core point. Noise point means, for example, I taken the minimum points is 3. If the given points are less than 3, that is called as noise point. If the given points are greater than 3, that is called as border point. If the combination of noise and border will be occurred, that is called as core point. So it contains both less than 3 and greater than 3 values is called as core point. That is noise point, border point, and core point. Now I will give an example, you will understand what is that point. So in the DB scan, what are the steps we have to do? First we have to take any unvisited point. That means we have to start from one point. Let us set that is A. And from that, the nearest neighbor points we need to calculate, and with that weights, let us assume that a weight is, that is a 500 meters as example. Then we need to take that minimum points and identify this is having a core point or it is having any core point into the given neighbors. So after we are calculating the density with the shop A and shop B, if the shop A is not a core point, the noise will be temporarily exist. We have to do the process until the last end. Now I will show you with example, you will understand what happened in this. So I taken the minimum points are 4 and the epsilon value is 1.9. So we need to calculate the Euclidean distance between the points. Let us assume that I taken total 12 points. So how to calculate the distance between the points? That means we are taken P1. So P1 to P2, P3, P4 like this up to all the points we need to calculate Euclidean distances. These are all the values we are getting. Whatever in this column we are getting, the same row as these values will be there. Like that. Next P2 to P1, P3. Observe this one, the diagonal values all are zeros. Why? Because P1 to P1 distance means square root of that value minus that value whole square plus the P1 minus P1 particular value whole square. So that value diagonally the values will be 0. So like this we are calculating the Euclidean distances to get these all the values. And how we are getting these values? P1 to P2 distance. So square root of 3 minus 4 whole square plus 7 minus 6 whole square. So square root of 1 plus 1, square root of 2, that value is 1.414. So I return that value here, 1.414. Similarly, all the values we have to calculate like this. P1 with all the points, P2 with all the points, P3 with all the points, and they don't want to calculate P1 with P1, P2 with P2, P3 with P3. Why? Because if you are calculating also, that values will be 0. So P12 with P12 0, P11 with P11 0, P10 with P10 0. Like this, so all these values will be 0. Why? Because that value will be comparable with that value, means we are getting the distances value square root of 0. That values we are getting like a 0 values. So like this we are calculating the distances. Then we have to identify if it is a noise point or it is a core point or it is a border point. Now see here, based on this data set, now we are written P1 contains what points are the minimum points are there. So in the P1 contains the minimum points in this are P2 is the minimum point and P10 is the minimum point. So that's why I written P2 and P10. Why? Because in the particular row, what is the minimum points are there, that points were written as neighborhood points. So next P2. So P2 contains the minimum values P1, then P3, next P11. So P1, P3, P11. Like that we are written all the points in this. Next we need to find out what is the noise point in this. So I taken one border point. So see here, these are the points we are taken. Now see this one, our minimum points they are given as 4, but P1 contains only 2 points. So directly we are written that is a noise point. Already given it is less than that value means we need to consider that as noisy value. Next one, P2. P2 also contains less than minimum points. And see here, by including that particular P1, see minimum, observe this one, by including P1 here having 3 points. Here by including P2 you are having 4 points. So that is reached with minimum point, that's why that is called as core value. Compulsory we need to include that point also into our example. Why? Because the P1, P2 self loop all are zeros. So that is also having minimum value. That's why we are combining P1, P2 and P10. It contains 3 values. It has 4 values. So that is a core. Why? Because that is reached with the minimum points, that is 4. Next value P3. P3 is having only 3 values, that is noisy. And P4 also having noisy value. Next it contains 5. That means more than that of minimum point. That's why that is called as core. That is equal to or greater than all our core points here. Now these are the core points here. Next what we have to do means whether we need to find out whether the noisy becomes the border or not, we need to identify that one. So first one, noisy. So see here, P1 contains P2 and P10, but P2 contains P1, P3, P11. So P2 will be a core point. So that means P1 is also border point. So P1 contains total, noisy and core, both will be there, that's why that is a border point. Next similarly P3. So P3 contains P2. P2 is a core and this is a noise, that's why this is a border point. Next here P4. So P4 contains P3. P3 contains P2. So those are noisy and border. So that's why noisy and core, that is the border point. And here also P6. P6 contains P5. P5 contains P4. P4 contains P3. Like that, that is also border point. Why? Because the noisy point will be exist in that point, including that particular value. So that's why these are the border points. This is about the given DB scan algorithm, density based scanning, spatial clustering and also applications of given algorithm in this. So based on that one we have to frame the graphs. So see here, so the P2, P10, whatever the points they are to be connected. So next point, so P2, P10, P12. So P2, P10, P12, that points we are framing one line. Next 1, 11, 3. So 1, 11, 3. The main border points, core points, whatever the core points are there, that core points we are written here. So in the previous example, the core points are P2 and P5, then P11, P2, P5, P11. So that values we are written here, P2, P5, P11, P5. These all are called as core points. Only core points will be shown in the DB scan algorithm. Only for that points only we are written the DB scan algorithm. Next one, optics. This is another type of density based clustering method. So optics means order points to identify the cluster structure. So how to identify the structure? So here we are finding two concepts. So it does not directly associate with the clusters. Create the reachability plot, visually represent the clusters. That means it is used to follow some order to calculate the core distance and reachability distance. Based on those two distances, we need to identify what is the density based cluster method and what we have to frame the form of graph. So the core distance, reachability distance means maximum of core distance between point P comma distance of P comma Q. Distance of P comma Q means square root of x2 minus x1 whole square, Euclidean distance, plus y2 minus y1 whole square, Euclidean distance between the points. So we need to take for this one. So after calculating with this, let us assume that P is a core point. The distance is 5 units. So further, if Q is 7 units, P away from P, that is 5 means the Q comma P is 7. Why? Because this is a higher value. Q to P means that value. In case P to Q means that value we are taken as, if you are taking the reachability distance P to Q means that value is 5. Reverse we are taking. So from that Q, whatever the value is to be there, that value we are considering here. So now we are calculating the ordered point. So Euclidean distance between the points. So from A to B, next A to C, then A to D we need to calculate. Next B to C, B to C, B to D, C to D. and those all the values we are calculating and identifying the distance values. Minimum distance values are A to B and C to D. So see here, A to B, that value is what we are taking the minimum value. So A to B 1.41 and C to D 1.41. So now we are written the core distance means whether A to B or B to C, that value is 1.414, C to D or D to C, that value 1.414. That is core distance values. Now we need to calculate the reachability distance between the points. So reachability distance means core distance with A to distance from A to B. So core distance with A to B 1.414. So that values, this diagonal value we don't want to calculate because A to A is not to be evaluated. So A to B, so A to B value 1.414. Next A to C 5.66. Next A to D 7.07. We have to frame the reachability distances. So this is about the optics algorithm in this. The same, whatever we have to be taken, the diagonal values will be calculated like this. So these are the density based clustering algorithms. Next, another density based clustering algorithm, that is DENCLU. DENCLU means density based clustering algorithm. So in this, what we are taken, so we need to find out the density based clustering algorithm. First step, initialize the parameters, and what parameters we are initializing means x comma xi comma sigma. Xm is the normal value, xm means mean value. X is our coordinate value, xi means mean value, sigma means standard deviation value. First we are calculating the smoothing parameter. Based on that, we have to calculate the local maximum value. What is local maximum means whether the converged value is passed, that means they won't reach with the condition or they are crossing the particular condition. So we need to stop the process, and in case that is not true means we have to do the same process. Count is less than maximum iteration means do the gradient value, and that value x plus epsilon into gradient value. Gradient means the difference value. Next, if it is less than threshold value, we need to set as true value. We have to stop the process with the new value. I will show you one by one. You will understand what happened in this. So first, let us assume that I taken the x value 0.1 comes 0.1. Our values a, b, c, d and sigma epsilon like this. First initial iteration, that value x naught value whatever we are taken as 0.1 and 0.1. Now we need to calculate iteration 1. So that is modulus sigma x naught minus a whole square. So 0.1 minus 0. 0.1 minus 0. This is for A. Similarly for B, C, D, E. Like this, all the pi c values we are calculated. And after calculating that all the pi c values, now we have to do the iteration. So here the maximum iterations is to be 10. First iteration, what we have to do? The gradient value means A minus x naught into pi naught A, pi A, B minus x naught into pi B and C minus x naught into pi C. So we are already having the values of pi A, pi B and pi C along with x naught and A values will be there. After substituting, the getting values are 0.43 and 0.432. So in the updated points x naught. So x naught value we are already having 0.1 and 0.1 plus our epsilon value they are given as 0.5. So 0.5 into 0.432 comma 0.432. So finally we get that value 0.316 and 0.316. Now the x modulus x1 minus x2, it is used to obtain the update the particular value. So after that we are getting that value 0.306. So now 0.306 is a greater value compared to 0.01. Now we have to do the same process until it reaches with the less than value. The same process we have to do x1 minus ia whole square. So x1 value whatever we are having 0.316 and 0.316. Why? Because in the previous 0.316 and 0.316 this is the particular value. Now we have to update that one. So finally we got that pi a value 0.905 and pi b 0.753 and pi c 0.753. Now based on that value, now we have to do again the same process we need to implement, and finally we got that value 0.0085, here 0.01. So now it is the less than that value, it is converged. Now we have to stop the process. That is about the DENCLU algorithm in this. This is about the density based clustering algorithms. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.